For question 1, I'll start by dividing 2,250 by prime numbers. Let's start by dividing by 2. This gives me 1125 divided by 3. We get 375 divided by 3 again, 125, and now divide by 5. Get 25, 5 again, gives you 5, and finally divide by 5 to get 1. So writing this as a product of powers of prime factors will be 2 to the power of 1 times 3 squared times 5 to the power of 3. For question 2, part AI, set A consists of this region here. So the elements in this region are 5, 7, 11, and 13. For part II, B union C is this region here. So the elements in this region are 5, 6, 8, 10, 12, 14, and 15. For part B, we have this symbol here, which means is not an element of, and Dominic is right because 9 is not inside C, is outside C. So what they're expecting us to say is something like, because 9 is not an element of C, or 9 does not belong in C. For part A of question 3, I'll first work out the scale factor between these two shapes, going from the large to the small one. Now I have two sides that are at the same place, the left part of the shape, 6 and 9.6. So my scale factor is equal 6 over 9.6. On top I put my target, my second shape, and then on the denominator my original shape, the starting shape. This simplifies to 5 over 8, and that's the scale factor to go from the large to the small shape. So now to find GH, which is this side here, let's label it as X. I'm gonna do GH equals the corresponding side on the large shape, which is 4, times my scale factor. Put this on the calculator if you want. The answer will come out to be 2.5 centimeters. And then in part B, I need to find BC, which is this one. Let's label it as Y. So BC times my scale factor will be equal to 5.7, which is the corresponding side on the small shape. Now if I rearrange this one, BC will be 5.7 divided by 5 over 8, and the answer to this comes out to be 9.12. For question 4, I need to find the perimeter of this shape. Note that the perimeter is made up of 3 semicircles. The two red ones have a diameter of 6, therefore the radius is equal to 3 centimeters. And in order to find the radius of the blue semicircle, I'll need to use Pythagoras theorem. So AB squared is equal to 6 squared plus 6 squared. So A and B is the square root of 72. You can simplify this to 6 square root of 2. Therefore, the radius of the blue shape is 3 root 2. So now I can find the perimeter. So perimeter equals 2 pi r1. Note that I have two semicircles with the radius 3, the red ones. If I put them together, I get a whole circle plus a half times 2 pi r, with r being 3 root 2. Now if I cancel out the 2's, I'll be left with 2 pi times 3 plus pi times 3 root 2. Now I want this as a decimal, so put this on the calculator and the answer will come out to be 32.2 centimeters. For question 5, let's start by finding the probability of losing, which is 1 minus the probability of winning, and this will come out to be 0.26. Now this is the probability of losing any given game. Evie is going to play 300 games. The estimate for the number of games that Evie will lose is equal to the total number of games times the probability of losing. Hence, I have 300 times 0.26, which comes out to be 78 games. In part A of question 6, I will subtract the powers, so I get m to the power of 7. In part B, for the left-hand side, I will add the powers, so k to the n plus 4 equals k to the 12. Therefore, n plus 4 must be 12. N comes out to be 8. And then in part C, the power of 2 will be applied in all terms, so I get 3 squared times x to the power of 6 squared, y to the power of 8 squared, so I get 9 x to the power of 12, y to the power of 16. The last two are done by multiplying the powers. In part A of question 7, expanding this expression will give me 4x squared minus 20x. And in part B, factorizing the given expression will give me y minus 5, y minus 4. In part A of question 8, 5.6 times 10 to the minus 3, it's 0.0056. And in part B, I'll first work with the denominator, and this is equal to 2.1 times 10 to the minus 4 plus 0.9 times 10 to the minus 4. So I'm making the powers the same, so I can add 2.1 and 0.9, which give me 3 times 10 to the minus 4. So now I can perform the division. 6 times 10 to the 3 over 3 times 10 to the minus 4. First, I'll divide the numbers at the beginning. 6 over 3 is equal to 2. And then these two, I will subtract the powers. So I have 7, which is basically 3 minus 4. And that's my final answer. In question 9, I'm given that the value of the car depreciates by 12% each year. Hence, the multiplying factor is equal to 88 over 100, or 0.88 for each year. Now I'm doing this for 3 years. Therefore, the multiplying factor is equal to 0.88 to the power of 3, and that's for 3 years. So, using the following formula, I can plug in the initial value in the multiplying factor, and this will give me 700,000 times 0.88 to the power of 3. Put this in the calculator, and it will give you 477,030.4, and if I round this, I will get 477,030. For question 10, I have to enlarge this shape with a scale factor of 1/3 and center 1,7. Start by locating the point 1,7, which is the center of enlargement. Then I'm going to join the center to the 3 vertices of the big triangle. Next step is for each of those red lines, go a third of the distance starting from 1, 7. So for example, for this line here, go a third of that, which is this point, and mark it. And then repeat with the other two lines. So I've got this point here and this point here. And finally, join those 3 points to have your image. For question 11, I'll start by finding the volume. The formula I'm going to use is density equals mass over volume. So 7.8 is equal to 1,950 over volume. So volume is 1,950 over 7.8. So the volume is equal to 250 centimeters cubed. Now the shape I have is a cuboid, so volume is equal to 4 times 5 times the width, so 250 is equal to 20W, so W is equal to 250 over 20, which gives me 12.5. For part of question 12, adding all the probabilities should give me 1. So I get x plus 0.15 plus 0.5 plus y plus 0.13 plus 0.03 is equal to 1. Therefore, x plus y is equal to 1 minus 0.15 minus 0.5 minus 0.13 minus 0.03, and if you simplify the right hand side, it will give you 0.19 as required. In part B, I'm just solving simultaneous equations, so let's write them down again. 3x minus y is equal to 0.09 and x plus y is equal to 0.19. And I'm going to add the two equations together. The minus y and the plus y will cancel out. So I get 4x equals to 0.28. So x comes out to be 0.07. And I'm going to replace x with 0.07 in the second equation. So I get 0.07 plus y is equal to 0.19. So y is 0.19 minus 0.07. Y comes out to be 0.12. And 0.07 and 0.12 are my final answers. For question 13 part A, I need to complete the tree diagram. Note that the probabilities on each split should add up to 1. So 0.7 and 0.3 add up to 1. These two should add up to 1. And these two should add up to 1. So the first one is 0.1 and the one below is 0.6. Then in part B, I need to work out the probability that Novak wins both games. So I need the following combination. So I'm just going to multiply 0.7 and 0.9 to get my answer. So 0.7 times 0.9 is equal to 0.63. For part A of question 14, I need to complete the cumulative frequency table using the first table above. So the first cumulative frequency is the same as the table above, which is 15. Then I'm going to add 16. This will give me 31 plus 21, 52 plus 14. I get 66 plus 8, 74 plus 6 equals 80. Then in part B, I'll need to draw the cumulative frequency diagram. Note that the x-coordinates of the points I'm going to plot are the upper bounds, this one, and the y-coordinates are the cumulative frequencies. And then I'll also draw an extra point, 50, 0, it's my x-intercept. So let's plot the points. And then I'm gonna join them either with a smooth curve or using my ruler and join them point by point using line segments. Now in part B, I need to calculate the median. I have 80 observations, so 80 over 2 gives me 40. I need the 40th observation. So I'm gonna go on the vertical axis, find 40 and then find the corresponding x coordinate, and the value on the x-axis comes out to be 74. Note that the mark scheme accepts values between 73 up to 75. Part D must find the interquartile range. Now the interquartile range is the upper quartile, Q3, minus the lower quartile, which is Q1. So first let's find Q1 and Q3. Now for Q1 I need to find the quarter of 80, which is equal to 20, so I need the 20th observation. And for Q3 I need 3/4 of 80, this is equal to 60, so I need the 60th observation. So I'm gonna do something similar to the median, but this time I'm gonna start from 20 and find the corresponding x value, and from 60 and do the same thing. And as you can see, I get 63 for Q1 and 86 for Q3. Let's write those down. So I get 63 and 86. So the interquartile range is 86 minus 63, which comes out to be 23. Again, the mark scheme accepts values between 21 and 24. In question 15, I'll first find the reflex angle C, marked in red, which is part of the hexagon, and then I'm going to use that to find the obtuse angle C, marked in blue, and finding that one will enable me to work out the value of n from the n-sided polygon above. So let's begin with the hexagon. I'm going to use the following formula. So with n being 6, I get 6 minus 2 times 180 must be equal to 90 plus 95 plus 149 plus 104 plus 57 plus C1. C1 is the reflex angle C. So 720 on the left hand side is equal to 495 plus C1. Therefore, C1 is equal to 225. Now, angles at a point add up to 360. So the obtuse angle C, the blue one, is equal to 360 minus 225, which is equal to 135. And now I can use the formula for the interior angles of a polygon, which is the following. So 135 is equal to n minus 2 times 180 over n. Let's cross multiply. 135n is equal to, and let's expand on the right hand side, 180n minus 360. I'm going to rearrange this. I'm going to take the 360 to the left, and then on the right I have 180n minus 135n. Let's continue here on the right. 360 is equal to 45n. So 360 over 45 is equal to n, and comes out to be 8. Note that for the second part of the question, instead of working with the interior angle, I can work out with the exterior angle, which is equal to 45, and the formula for the exterior angle of a regular polygon is equal to 360 over n. Solving this one will give me 8. Let's start question 16 by letting x be our recurring decimal, so that's 0.1767676 and so on. Now let's try and locate the first repeating pattern. We are repeating 76, so this is the first repeating pattern. Note that if I want to go from the decimal place to the beginning of this pattern, I have to move my decimal 1 point to the right, so that's like multiplying by 10, while if I want to move from the current decimal position to the end of the repeating pattern, I have to move the decimal 3 points to the right. That's like multiplying by 1,000. So we've got 1,000 and 10x. Let's write those down. 1,000x will give me 176.7676 and so on, while 10x will give me 1.7676 and so on. So now I can subtract those decimals. Note that on the right hand side the decimals will all cancel out because they're exactly the same. So I'll get 175, and on the left hand side I'll have 990x. Therefore x is 175 over 990. If you simplify this, you'll get 35 over 198 as required. For question 17a, I'm given that f is inversely proportional to the square of r. Therefore, f equals to k, which is a constant, over, because it's inversely proportional to r squared, and I need to find k now. I'm given that when f is 36, r is 4. Let's substitute those values. So k is equal to 36 times 4 squared, which comes out to be 576. Don't stop there. The question is asking for the formula, so I need to write f equals 576 over r squared. Writing the formula without the f will not give you full marks for this part. And then in part B, just gonna substitute the value of r into my formula. So f equals 576 over 48 squared. Put this on the calculator and you'll get 1 over 4, and that is my answer. For question 18, I'll need to find the lower and upper bounds for the total length and for the panel length. The total length is equal to 50 meters, correct to the nearest 5 meters. So I'm going to take the 50 plus or minus half of 5, that's 2.5, and find the two bounds. So I get 47.5 and 52.5 meters. Now for the panel length, this is equal to 1.3, correct to the nearest 10 centimeters. Now I need to convert the 10 centimeters into meters. That's 0.1 meters. I'm gonna divide that by 2, get 0.05 meters, and add and subtract these to 1.3. So I'll get 1.25 meters for the lower bound, 1.35 meters for the upper bound. Now the number of panels is equal to the total length divided by the panel length. Now if this is not an integer, then I'll have to round up because I'll have to buy that amount of panels. So the lower bound for that is equal to the lower bound for the total length divided by the upper bound for the panel length. This is 47.5 divided by 1.35, which is equal to 35.2. Therefore, we must buy 36 panels. The upper bound for the number of panels is equal to the upper bound of the total length divided by the lower bound for the panel length. This is equal to 52.5 over 1.25, and this comes out to be exactly 42 panels. Note that for these two there is a difference of 6 panels. So to find the greatest difference, I'm going to take this number, multiply by the cost, which is 8.65, and this will give me my answer. So cost equals 6 times 8.65. Put this on the calculator and you'll get 51.90. For question 19, we'll need to find the distance AB added to BC, and then find the distance AC and subtract to find the difference. So prove is the one that goes from A to B and then from B to C. So I'll find the magnitude of the two vectors AB and BC and add those two together. To find the magnitude or modulus, you just use Pythagoras theorem with the two components. So for AB, I have 7 squared plus minus 2 squared, and then take the square roots. This will give me square root of 53. And for BC, I have the square of minus 3 plus the square of 5. Take the square root of that, you're going to get square root of 34. Adding those two, square root of 53 plus square root of 34 will give me 13.1 kilometers. And then for Young, we'll need to find the vector AC. Now AC is equal to AB plus BC. Note, I'm not having modulus right now. I'm actually adding the two vectors. So 7 minus 2 plus minus 3, 5 will give me 4, 3. And I'm going to find the magnitude of vector AC. So I've got 4 squared plus 3 squared. Take the square root of this and you get 5 kilometers. So 13.1 minus 5 will give me 8.1 kilometers. For part A of question 20, I have a curve with a maximum at 3,5, and then I have 3 transformations that will affect these points. Now for the first one, 2f of x, that is a stretch along the y-axis by scale factor of 2. So x coordinate stays the same, y coordinate doubles and becomes 10. For the second one, f of x minus 7, this is a translation by 7 units down. So x coordinate stays the same, y coordinate is reduced by 7. So 5 minus 7 is minus 2. And for the last one, f of minus x, this is a reflection on the y-axis. It affects the x coordinates. The positive become negative, the negative become positive. So I've got a 3. Once reflected, will become minus 3, and the y coordinate stays the same. Now for part B, I have a different curve, a quadratic one. I'm given the equation. Let's assume that this is equal to f of x and is being transformed under the translation to 0. This is 2 units to the right. So writing this in a functional form like I had in part A will yield y equals f of x minus 2. So what I have to do now is go to f of x, which is this one, and replace those x's with x minus 2. So I'll get y equals x minus 2 squared plus 7x minus 2 plus 20. The question requires the answer in this form, so I'll need to expand and simplify. So y is equal to x squared minus 4x plus 4 plus 7x minus 14 plus 20. And if you simplify this one, you'll get y is equal to x squared plus 3x plus 10. For question 21 part A, I need to differentiate. This involves multiplying the coefficient of each term by the power and then reducing the power by 1. So for x cubed, I will get 3x squared minus, and then I get 2 times 2 is 4x to the power of 1, and the minus 9x will be minus 9. The plus 15 becomes 0 upon differentiation, so no need to write it. In part B, I need the values of x for which I have a positive gradient, so I need to solve 3x squared minus 4x minus 9 is greater than 0, that is dy dx is greater than 0, because the question requires an answer to 3 significant figures. I will not try and factorize, it doesn't factorize, so I'll use the quadratic formula. Now a is equal to 3, b is equal to minus 4, and c is equal to minus 9. Let's substitute those values. So minus 4 plus or minus the square root of minus 4 square minus 4 times 3 times minus 9 all over 2a, therefore 2 times 3. I'll put this on the calculator. I'm going to do it step by step. So I'm going to put this on the calculator first, and this will give me 4 plus or minus the square root of 124 over 6. Now, as decimals, this will give me 2.52 or minus 1.19. Now, these are my critical values. So if you consider the quadratic function above, this one, that's a positive quadratic. It's 0 at minus 1.19 and 2.52. It's greater than 0 to the left and right of those numbers. So final answer, x less than minus 1.19 or x greater than 2.52. Now this diagram is just to give me a visual representation, doesn't get any points. For question 22, I need to find the percentage of people aged more than 55 years. Now, this is equivalent to finding the area that corresponds to people that are aged more than 55 years. I don't know the actual frequencies, but I can work with the areas. Now, I'm going to summarize all my workings on the table. You don't have to do that. I'm going to write more than what is actually needed. So coming down here, I will create a frequency table. Now my age groups are 20 to 25, 25 to 30, 30 to 40, 40 to 50, and 50 to 75. To find the area, I'll need to multiply the width of each bar times the height. Now the widths, the class widths, are the difference between the lower and upper bound of each category. So for the first one, 20 to 25 is equal to 5. Similarly, 5, 10, 10, and 25. Now for the heights, note that I don't have any scale on the vertical axis. I'm gonna put my own scale. It doesn't matter what scale you put, because at the end, because I'll find a percentage, the scale will be irrelevant. So I will personally use a scale of 1 small square being 1 unit. Therefore I have 10 here, 20, 30, 40, and 50. So for example, for the first bar I have 16, for the second 50, and so on. So let's complete the table. 16, 50, 33, 19, and 9. And then to find the frequency or the area, just multiply class width by frequency density, and I will get 80, 250, 330, 190, and 225. If you add all those up, you'll get 1075, and this is the total area based on the scale I have chosen. So if you've chosen a different scale, you'll get a different number. This number will be the denominator of my fraction. Now I have to find the numerator of my fraction, and to do so, I'll need to find the area for more than 55 years. So I want this area here. So this area goes from 55 to 75, so it has a width of 20, has a height of 9, so the area is 180. So now I can work the percentage, which is equal to the fraction I have, 180 over 1075 times 100, and this gives me 16.7%. For question 23, I'll first work with the division here, and then once I simplify that one, then I will subtract 2x. So I'll start by flipping the second fraction and changing the division to multiplication. So x squared minus 4 over 1 times x over 4x squared minus 7x minus 2. Let's factorize x minus 2 times x plus 2 over 1 times x over x minus 2 times 4x plus 1. Now I can simplify the x minus 2 with the x minus 2, and if I multiply out, I'll get x plus 2 over 4x plus 1. So now I can move on and subtract the 2x, so I get x times x plus 2. I'm rewriting my answer from above, minus 2x over 1. I'll multiply the second fraction by 4x plus 1. So this will give me a single fraction with numerator x plus 2 minus 2x 4x plus 1 all over 4x plus 1. So let's expand the numerator. I will get x squared plus 2x minus 8x squared minus 2x over 4x plus 1. Now I can cross out the 2x with the minus 2x, so I'll be left with minus 7x squared over 4x plus 1, and this is as far as I can simplify. For question 24, I'll start by writing everything as powers of 2. So 16 to the power of x will become 2 to the 4 to the power of x, so that's 2 to the 4x. 8 is equal to 2 to the power of 3. So if I replace those numbers into the equation, I'll get 2 to the n equals 2 to the x squared times 2 to the 4x times 2 to the 3. And then because I have multiplication, I will need to add the powers. So 2 to the power of n equals 2 to the x squared plus 4x plus 3. And now I can equate the two powers to get n equals to x squared plus 4x plus 3. The target now is to make x the subject. I know it's tempting to factorize, but don't do that. This will lead nowhere. The way to proceed is to complete the square. So let's focus on the x squared plus 4x. Now in our case, b is equal to 4. So b over 2 is equal to 2. so x squared plus 4x will become x plus 2 squared minus 2 squared, so x plus 2 squared minus 4. So let's take this and go back to the expression for n equals to x plus 2 squared minus 4 plus 3. So n is equal to x plus 2 squared minus 1. I'll rearrange now to make x the subject, take 1 to the other side. So n plus 1 equals x plus 2 squared plus or minus the square root of n plus 1 is equal to x plus 2, and then minus 2 plus or minus the square root of n plus 1 is equal to x. Now we are given that x must be greater than 0, so to get x is greater than 0, we need to have the positive here, so it's going to be minus 2 plus something to make the x being greater than 0. So x equals minus 2 plus the square root of n plus 1. So this is my answer, but still I need this to be large enough. So let me write on the side, since x is greater than 0, then the minus 2 plus the square root of n plus 1 must be greater than 0. So square root of n plus 1 is greater than 2. N plus 1 must be greater than 4. So n is bigger than 3. And this answers the second part of the question that says state any restrictions on n. Now you could have figured out the last restriction from this expression here. If x is greater than 0, then substituting this into the x here will give me an n value of greater than 3. For question 25, I'll start by setting up an equation using the area to find the value of x. The formula for the area is the following. But because I'll be using angle A, I'll change this formula as a half of BC sine of A. So let's substitute what we know in the formula. X squared plus x minus 3.75 equals to a half. 2x minus 1 times 2x plus 1 sine of 30. So x squared plus x minus 3.75 equals a half. Let's expand the brackets. 4x squared minus 2x plus 2x cancel out, minus 1 times sine of 30, which is a half. So x squared plus x minus 3.75 equals to a quarter of 4x squared minus 1. Expand the brackets, x squared plus x minus 3.75 equals to x squared minus 0.25. Now the x squared and the x squared cancels out, so x equals to 3.5. So I can go back to my shape, replace x with 3.5. So AB will be 6 centimeters and AC will be 8 centimeters. So now I'll need to find side AB. I cannot work out any of the angles without BC. So I'll use the cosine rule to find BC. So the formula for the cosine rule is the following. So BC squared is equal to 6 squared plus 8 squared minus 2 times 6 times 8 times cos of 30. So BC is the square root of that, gives me 4.106283 141. So let's go back to the shape. That's 4.1. And now I need to find the size of the largest angle. Obviously, the largest angle is across the largest side, which is this one, B. Now, based on the information that I have, I can use both the sine rule and the cosine rule. Now, I will proceed with the cosine rule. There's a reason for that. I'll do that and then I'll explain why I prefer the cosine rule instead of the sine rule. So let's go and use the cosine rule again. So if I rearrange this formula, I will get cos B is equal to A squared plus C squared minus B squared over 2AC. Let's plug in the values. 4.1 with all the digits squared plus 6 squared minus 8 squared over 2 times 4.1 with all the digits times 6. This will simplify to minus 0.226 and so on. So B is equal to the inverse cos of this number. Put this on the calculator and you'll get an answer of 103. Now, as I said before, you could use the sine rule, but you have to be careful with the sine rule. If you decide to go with the sine rule, you have the following: 4.10 and so on over sine of 30 equals to 8 over sine of B. So sine of B is equal to 8 sine of 30 over 4.10 and so on. B is the inverse sine of this expression. So if you put this on the calculator, you'll get an answer of 77 degrees. Remember, the sine rule has an ambiguous case. It always gives a second value, which is 180 minus the first one. So this is the correct answer. That's why I don't like the sine rule. You have to bear in mind that there's always a second case and you have to investigate whether this second case is the valid one or not.